Okay. Good morning, students. And this is Shivaj Patel, and welcome to Maths Chef YouTube channel. Right. So yesterday and day before previous class and before the previous class, we have discussed about the relations, equivalence relations, symmetric, reflexive, symmetric, and transitive. And yesterday have the equivalence class. What is the meaning of definition of equivalence class? Again, today we will revise the some definition, same definition, because in if we ask in board exams, so it will helps to remember. Okay, so equivalence class means, okay, then the equivalence class of A, this you have to read as equivalence class of A is equal to set of X, right? Set of X such that X belongs to A, right? And X or A, relation is condition. Okay, there should be some operations. Okay, like that. If set A has condition, okay, then okay, X minus A divided by 2. Okay, X minus A is greater than 5, and X plus A is equal to 10, whatever it may be. Okay, so here A is common, right? These are random numbers. X belongs to A. Okay, so from this A, you get the different X values. With respect to A, you will get the different X values. Okay, so that is the X. Okay, that's the condition. R is the any mathematical operation or condition, right? That's why the equivalence class of A, how to read is equivalence class of A is equal to set of X such that X belongs to A and X are A, right? In definition, verbal form, right? Let R be an equivalence relation. Okay, this is the equivalence relation, means it has both three: reflexive, symmetric, and transitive. Right? This R should be have reflexive, symmetric, and transitive. RST. Okay, equivalence relation on set A. If A belongs to A, right? The generator A belongs to A, then the set of all elements X belongs to A. Okay, right? They will consider. If A belongs to A, then set of all elements X belong to A such that X or A is called equivalence class. Right? Then the set of all elements of X belongs to A such that X or A is called, okay, is called equivalence class of A. Right? This is the full reading. Okay, and divided by close bracket of A. Right? This is the definition of the equivalence class. Based on these definitions, and we will solve the first problem based on the which one? Equivalence relation. Only what are the functions given sets are equivalence, reflexive, symmetric, and transitive, and I have to show the equivalence relations and equivalence class. In this beginning first chapter, means first concept, first part of the relations, only three possibilities. First, you have to show reflexive, symmetric, transitive. Second thing is that if it is possible, all three, then I have to show the equivalence relation. Again, I have to show the equivalence class. Okay, so I divided the two classes. So to get into the deep understanding, first I will solve the problem based on the equivalence relations. Then we will solve the question based on the equivalence class, right? Okay. First question is the questions based on the reflexive, symmetric, and transit. Right? The relation R on the set A is equal to 1, 2, 3, 4 up to 14, defined as R is equal to, okay sir, how to read this one as R is equal to set of X, Y such that X and Y belongs to A, and the condition is 3X minus Y is equal to 0. 3x minus y is equal to 0. Right? Or the condition, the difference. Okay, sir. R is the subset of A. How it subset? With the condition. Right? R is the subset of a condition, because there should R is a set where this condition is allowed only. This relation is allowed only. Okay, sir. This mathematical operation, this condition is allowed only this R. Okay. just write the condition, the new set. Solution is, okay sir, the condition is what is R? R is 3x minus y equal to 0, implies that, okay sir, y is equal to 3x. Y is equal to 3x, right? See, here you should take the maximum values. Okay, you should get the y should not reach the 14. Okay, so I am writing this as set of R, right? Okay, so what can I write? 1 and 3, right sir? If x equal to 1, y equal to 3, right? And 2, 6, right? If x equal to 2, y equal to 6, and 3, if x equal to 3, y equal to 9, and if x equal to 4, y equal to 12 over. If x equal to 5, y becomes 15. So it is not mentioned. Okay, I have the limit 1 to 14. Yes, the set of R is 1, 3, 2, 6, 3, 9, 4, 12. Yes, this is the subset, right? With the condition relation, right? So first one is, okay sir, what am I writing here? Here our aim is to show either reflexive, symmetric and transitive. Only the up to 5 to 6 question how to show other is reflexive, transitive and so I am not writing here, just okay. The question is, I will read the question on screen in front of you. Determine whether each of the following relations, okay, determine whether each of the following relations are reflexive, symmetric, transitive. First question, second question, third question, okay. Our aim is to, okay sir, produce the find out the reflexive, symmetric and transitive. First one is, right? First one is the reflexive. You check the reflexive relation. So I am trying to improve the handwriting, but still, okay. So the mind and hand, they are not coordinative, right? Okay. Why the handwriting is ineligible means, okay, the mind speed and the working speed, they are not in a coordinate manner. That's the problem. Reflexive relation. See, again, let me consider, right? Let it be. What is the reflexive relation? We should show, make it A, R, A, and such that, okay, such that A and A, okay, any condition or definition belongs to R and A belongs to A. Here our A is 1, 2, 3, 4, right? Say sir, A and belongs to R, but here see the 1, 3, 2, 6, 3, 9 and 4, 12. So there is no the reflexive property, right? See, I can take 1 and 3 and 2 and 6, whatever it may be. Just you can take only one value, okay? You can write here also better. Does not belongs to R. Not okay. This is the 1, 1, right? 1, 1. Okay. See there how elements now. Again you can take any elements. 2 and 2 also not belongs to R. Have to show whether one element, okay sir, one common element, you can take 1 or you can take 14. If does not belong to R, then therefore R is not reflective, right? Therefore R is not reflective, reflexive relation, right? Second one is symmetric. Second one is symmetric relation. Okay. What the condition is? If A or B implies B or A, that is condition. If A B belongs to R, implies B A must be belongs to R. Okay, and A B belongs to A here, and A B belongs to A here, right? For this condition, right? So take any examples here. You should get 1 and 3. Okay, sir. But okay, can write now as 1 and 3 belongs to R, right? But 3 and 1 does not belongs to R. There is no 3 1 R, no? Therefore R is not symmetric. R is not symmetric. No, sir. Next, transitive. Yes, just note on it. Okay. Symmetric is over. Transitive, right? Third one is transitive. Okay, for this condition is if A or B and B or C, right, implies that A B belongs to, okay, this not implies here, more condition. This implies that A or C definition. Okay, that is in terms of set, I am writing A B belongs to R and B C also belongs to R, implies means then, right? A C belongs to R is the condition. Okay, let's take it, sir. Right? We have any relations, right? We have the one things. Okay, we have not common, na? 1 and 3 have, 2 and 6 have, 3 and 9. So we do not have 2 y terms, right? 2 b terms. Let it be, right? Okay. Let now take the examples. 1 and 3 belongs to R, right? And 3 and 9 belongs to R, right? But okay, but right, A and C, but 1 and 9 does not belongs to R, right? 1 and 9 does not belongs to R. Therefore R is not transitive, right? Transitive. Yes, this is the only method. Okay. Only the trick or the idea, the skill is writing this set. Again, because this is the infinite. You can write plus, you can write division, you can give the model, you can give the odd number, something else, power, something like that. Here the tricks, okay. How to do, you have to understand this one. What are the condition? Remaining is only theoretical part only. But writing the set according to that condition is a quite difficult task here. Means we have to think in our mind. Because if it is information, if the evaluation is given to the R rational numbers, so it's not possible to check the all rational numbers, because now we should be aware of the every point, okay, especially 0, the positive and negative and reciprocal and power numbers, okay, whether the condition is applicable or not, whether the condition is giving the good result or not, okay. So this is the condition. They, without this condition they will not give, okay. Only thing is here this one only. according to this, you have to write the set, this set. If you taken this set, this becomes very easy. Okay. In competitive exams, okay, just you can take this sum set and you can do the all operation. But in board exams, this is the proper step. Okay. First, you have to take the question and write the solution. R is equal to condition, right? Sorry. Then the set of the R with respect to condition becomes 1, 3, 2, 6, 3, 9, 4, 12. And first, I have to show the reflexive. Take the write the definition. Okay. If you're in board exams, okay, not necessarily write the definition, write the answer and take symmetric and take the 2 elements. So show the symmetry if possible. And again take the 3 elements. Okay. And show the transitive. If all 3 are holds, the set is okay. The set the R is symmetric, reflexive, symmetric, and transitive. Then automatically R becomes equivalence relation. Right? This is the basic question. Okay. We'll see the next question again. Next question is next question is okay. Check whether the relation on R. Okay, this is the set of real numbers. Okay, real numbers is very danger. So you can't imagine the length and breadth and depth of the real number, right? Because in power it has, in decimals it has real number, in fractions it has real number, in zeros it has real number. It can't exact define what is the real number. Okay, any number is a real number at right now. Okay, any number, any digit, any decimal, any fraction is real number. The condition is the R is a set of AB such that A is less than or equal to B cube. Right? How to show R is whether reflexive, symmetric, and transitive. Our motto is here to show whether R is reflexive, symmetric, and transitive. Let's okay, sir. The solution is right. What the given is, first you take the given condition, right? Given is R is equal to, right, set of A, B such that A is less than or equal to B cube, right? B cube, right? One thing I am understanding, see, those who are watching my video, please look at my pronunciation instead of the writing, because this words may be different. So those who are not disturbing mindset, so that is quite difficult. Okay, I'm reading. So in reading you get the clarity. The what the A is, what the B, what the reciprocal, what the power. Okay, I'm reading. R is equal to set of A B such that A is less than or equal to B to the power cube 3. Right? Have to show and A B belongs to. Right? A and B belongs to R, set of real numbers condition. Yes, they given A and B together. First we'll say the see this is not possible to draw the exact set, because if you want to take AB, right, less than means B cube, okay. Whatever may be, anything value, okay, you can take also that not creates 1, 9, this is right, but again if you taken 1 by 3 less than 1 by 9, yes, because real number we can take any value, random value, okay. If A is taken if B taken as 1, if B taken as 9 and A should be, means A should be less than, means if B can taken 1, A should be 0. If B taken 2, A should be 1, 2, 3, 4, 5, 6. If B taken C, this is the possible condition, not possible condition. Let's see. That when you're taking the real numbers now, that is the quite difficult. Okay, you should take the all positive numbers, negative numbers, and fraction numbers, especially reciprocal of 1. That is the thing here. Okay, let's see. Okay, I will be taking here as a as 1 by 2. A is equal to 1 by 2. So we'll start the solution is, we'll show now. Okay, in book how they given, first they will define the function characteristic. R is not reflexive, R is not symmetric, R is not transitive, but here it's not possible because they have the clear cut idea something else, but in those who boarded they can write after solving the question, but before solving the question is not possible, it's not right way also. Let's just consider now A is equal to 1, 2, 3, something else, right? A is equal to 1 by 2. See, if I take a 1, it result is true, but 1 by 2 it's not true. Let's see. And 1 by 2, okay, I have to show, okay, what the ARA? ARA implies A have to show A is less than A cube, implies that what is 1 by 2 is less than or equal to 1 by 2 cube. This is equal to 1 by 2 less than or equal to 1 by 8, right? 1 by 2 is greater than 1 by 8. Therefore, R is not fixed. So this is the method. ARA defined as, implies as A is less than or equal to A cube, putting the value, okay, implies, and this is not equal to, okay. This is also implies 1 by 2 is not equal to 1 by 8. Therefore, R is not reflexive. Okay, they given R. Okay, if I take an A is equal to 1, okay, yes sir, then ARA becomes, okay sir, the 1 is less than or equal to 1 cube, this becomes true. Okay, with respect to positive integer is right. With respect to positive integer, this may be right. Okay, that's why the equivalence class, it creates it with mutually disjoint subsets. If R is the equivalence class, equivalence relation, then the value, one value, generator of the R, the relation creates, okay sir, the mutually disjoint subsets. Okay, that's why. So if I take and see, if I take this condition, again I can write this one as holds good. Okay, for this one. Okay, R is for not which one? Reflective. Second one is, now take A is equal to 1 by 2 and B is equal to, right one, take any value, small value or greater value, okay, 1 by 4, right? Or the condition is ARA, ARB implies BRA. This implies, you will write in the bigger values. ARB implies BRA. Okay, I am taking random value. If correct answer is correct, I have to change the values. Okay, right. What is AB? Okay, then this implies that 1 by 2, okay, less than or equal to 1 by 4 cube, right? This implies 1 by 2 is less than or not equal to 1 by 4 cube, because 1 by 2 is greater than 1 by 4 cube. See here, we don't need to write the expansion. If it is okay, 4 into 4 60, 60 into 4 64, you can write, but in exam, if you give 4 to the power n, that's not possible. It will be, okay. Again, b to the power, so this is not possible. Again, all automatically this is not symmetric, but we'll show. Again, b to the power less than or equal to a cube implies that again, and what is the value? B to the power 4 less than or equal to 1 to the power cube. This implies that 1 by 4, right, less than or greater than or equal to, less than or equal to, less than or equal to 1 by 8. This is also not true. because 1 by 4 is greater than 1 by 8. Therefore R is not symmetric. R is not symmetric, right? Okay, so in the book, the example they taken, B is equal to 1 and R is equal to 2. Right? B is equal to 1 and R is equal to 2 they taken. That will be, okay, and third last one is transitive. Okay, transitive. Can I erase this one? Okay. Next one is transitive. Further condition is if A or B and B or C implies A or C. Means you have to show if A is less than or equal to B cube and B is less than or equal to C cube, this implies that A is less than or equal to C cube. Right? I am erasing this one also. Right? Our condition. Let's take again A is equal to 1 and B is equal to 2 and C is equal to 3. Let's check random value. Okay. Then let's check. Okay, sir. Now and okay, A is less than or equal to B cube implies, right, 1 is less than or equal to 2 cube. Right? This is right. And B is less than or equal to C cube implies that 2 is less than or equal to 3 cube. Right? This implies that and A is less than or equal to C cube implies that 1 is less than or equal to 3 cube. Right, sir? This is true, this is true, this is true. Right? Only for the positive. Let's take this A is equal to, let's change this symbol. Okay, let's change the B is equal to 1 by 2 and C is equal to 1 by 3. Right? Okay, and then A is less than or equal to B cube implies that 1 is less than or equal to 1 by 3 whole cube. This implies 1 is not equal to 1 by 3 to the power 3. Right? 1 is greater than actually. Right? Similarly, B is less than or equal to 3 cube. Okay, C cube. This implies that what is 1 by 2? 1 by 2, okay, is less than or equal to 1 by 3 cube. This is also not right because 1 by 2 is greater than 1 by 3 cube. 1 by 2. Okay, therefore A is less than or equal to C cube. This implies that 1 is less than or equal to 1 by 3 cube. This is also not right. Okay, see sir, this I am going to take only for the understanding purpose, but this is the exam purpose. Okay, in real number you should check this one, right? Therefore R is not transitive relation. Right? They are also defined as not transitive. This implies right. In yesterday class you have started the one which one? GCD of the ABN is 1. Right? Similarly, they have GCD. Okay? In exam they have this condition is very dangerous. Okay, mathematics condition in this relation. Okay, because now we have to understand this one while choosing this condition and this relation. Okay, set. What is the condition? The set. The set and condition defines the question. What we should do tells the question what we should, what is expecting such that. Okay, so quite extraordinary minds and some very intelligent persons, by seeing the relation and the effect, they will define as if the equivalence relation or not. Yes, sir. In computer exams, in MCQs, that is the huge benefit for that the ultra mindset students. Okay, so ultra mind students, because now by seeing that one, okay, that is how it is possible in relation. 1 by 3 you can take 1 by 2 and 1. You can take 1 and 1 by 2. That's never possible. Never ever possible. Right? That's the beauty. Okay, let it be there. Okay, this is the question. We'll solve it again. Next question. Okay, sir. Next question is question number 16 and quite theoretical and quite lengthy also. Let's see. Okay, sir. The question is like that. See, the books they given quite lengthy, but I shorted it to make it to acquire the limited area. So R is equal to the relation. Okay, sir. Set of the triangles T1 and T2 such that T1 is similar to T2. Similar. Okay, sir. There is similarity. T1 is T2 is similarity. Similar. Okay, right? And T1, T2, T3 belongs to A is a set of triangles T1, T2, T3. Right? And T1, they given the sides. T1 with the lengths of 3, 4, 5, and T2 with the sides length is 5, 12, 13, and T3 the sides with 6, 8, 10. Okay, this is the condition. And same question, there are two questions. Show relation R is the equivalence relation on A. Equivalence relation on A. And which triangle among T1, T2, T3 are related? Right? This is the question. Have to show it is equivalence. Then if it is equivalence, then which of the following triangles are related? Right? First solution is first one about the reflexive, right? Again, let take T belongs to R, and again T is similar to T, right? Okay. Therefore T and T belongs to R, because the relating only one triangle, but almost always it is similar to itself. Therefore T and T belongs to R. Therefore R is reflective. R is reflexive. Then take the symmetric. Okay, symmetric. Okay, I had taken T1 and T2, right, belongs to R. Let. Okay, let this is the only one. Let. Okay, you can take R also. You can take the. Okay. So then if T1 is similar to T2, right, sir? This implies that T2 is similar to also T1. If T1 is similar to T2 and T2 also similar to T1, you should take it because their given condition is there. Okay, must be similar. Right? Therefore, R is symmetric. R is symmetric. Let's check the transitive, right? Transitive, this I am writing. Okay, transitive. Okay, let's take the T1 and T2 and T3, okay sir, belongs to R also. Okay, if, right sir, if T1 is similar to T2 and T2 is similar to T3, this implies that, okay sir, T1 is similar to T3 because T1 and T3 belongs to R. See here we cannot define this definitions because if 1 is similar to 2 and 2 is similar to 3, then 1 and 3 are always similar. Okay, they given also same thing also. Okay, so here you should take the before one. Let you writing na take x belongs to this belongs to A. Okay, in the symmetric also T belongs to A. Okay, yes. So this implies that T1 and T2 belongs to R. Here you can, after proving the symmetry, reflexive, transitive, then you can tell the T1, T2 belong to R. Before you should take the T1, T2 belongs to A. That is the method definitions. Okay. So here also like that. Should take the, again I am waiting. Should take the A. Yes. If T1 is equal to T2 and T2 is equal to T3, okay, this implies that T1 must be T3. One condition is solved. Okay, another one is there. But which triangles among T1, T2, T3 are related? Okay, sir. Let's check this one. Okay. See, I am waiting. See, if triangles are similar, okay, if triangles are similar T1 and T2 and okay, T2, T1 and T3 and T2 and T3, these are the possibilities of similarity. Then I am writing, okay, then the corresponding parts of the triangles are also equal. Like the ratio corresponding parts of the congruent triangles, similar for theorem, corresponding parts should be ratio. So what I am writing here, I am taking the corresponding part should be equal. Okay, I am taking T1 by T2. What is the T1 is 3, 4, 5 divided by, see, I am writing here corresponding part 3 by 5 and 4 by 12 and 5 by 13. So here I am not seeing any common residual parts, ratios. Again I am taking T1 and T3. Okay. This is the method you can write this also, but you have to mention, let take the T1, the ratio. If the triangles are similar, then the corresponding parts, ratio of the corresponding sides also similar. Means okay, right? Have to write down. So again 3 by, and this is what, 3 by 6 and 4 by 8 and 5 by 10. Okay. This includes 1 by 2, 1 by 2 and 1 by 2, right? Therefore, so 1 by 2, 1 by 2 getting the common, reciprocal means corresponding parts are equal. The ratio of the corresponding parts are equal. Therefore, by showing T1 and T3 are related. Okay, this is the beauty of the congruence. Okay, similarity. Okay, if the two triangles are similar, their corresponding parts are similar. Okay, means that ratio of the ratio of the all sides. Okay, sir. The ratio of the all corresponding sides are similar always. That is called similarity. Okay, in size and in size it may be different, but in shape is same. In size it may be different measures, but in shape it is same. That's called similarity, right? Okay, sir. This is the theoretical exam, but most potential question for exam also. Okay. Let's see, solve the one more question. I think so. I set the one more question for. Okay. That not necessary. Already I solved the question. Is A minus B is divided by 2. That's the same question. Okay. Again here. Here I am mentioning again. So we will solve the. Okay, sir. In next class I will solve the question different questions. Question based on the equivalence class and some different questions. Time is up. And okay, this is the questions. I solved 3 or 4 questions, I think so here. So and compared to the class 12 mathematics is quite okay. What do you call it? Instead of telling the complex, it's quite difficult to grasp it, understand it. Okay, it's almost because the board exams now in all India, your high school 10th also, in PUC also, and 12th exam also, it has quite applied past. Because now, why it is quite difficult means in class 11 we taken it as a very easy. Class 11 is the autonomous, in the college exam you can pass it and you could have passed also. But here, without basics, without strong fundamentals, you clear the class 11 exams. Like class 8, class 10. Why board exam is quite, many students are failing because they have not felt the board exams feelings, the board exams real life, the real board exam feelings in the previous classes, 8th or 9th. Same in class 11th also. Means if the government put the board exam for the class 11, class 12, then you will treat the same year as same. Because every year, the second year is completely the foundation. Class 11 is the foundation courses, foundation classes, foundation syllabus for the class 12 exam. But what students thinks is class 11 is easy. College will pass us at any condition, and class 12 we will see in the class 12. That's the problem. Okay. This congruency, the class 8th or class 9th or 8th concept, I think so. Let it be. We will solve the question again. Next class we will solve the different questions. Okay. Thank you for watching.